me, get this out here. And just because, again, I'm kind of there's some information here that um, we've definitely gone over, and it strikes me as very odd that I know I've said this at least 3 times. So for people to not understand this, I'm quite confused. So, firstly, so I was obviously all of you guys should have gotten your quiz 8s back last night. That all the quizzes were graded. I also started sending back the some of the midterm corrections. So some of you guys should have received your midterm corrections. Not all of them are back yet, but as I promised, you should all have your midterm corrections back no later than tonight. And then because of how Blackboard updates, you will expect to see Blackboard fully updated by tomorrow. So, I'm going to make sure that all the midterms are graded. Your Blackboard grades are going to be in. And then everything that I have from you is going to be available on Blackboard starting, quite literally tomorrow after the nightly refresh. So just for the record, tomorrow, what I really want most of you to do is just go on Blackboard, make sure that your grades match on Blackboard, that they do the quizzes that I sent you back, and also again, as I mentioned already, for some of you I am straight up missing like 1 or 2 quizzes, and you've never contacted me about a makeup. So as it stands, it's a 0, and it's really, really late. So I don't really know what to do about that because, I'm pretty accommodating in that fact. But if you don't come talk to me, then I can't give you a makeup. So, okay. So as far as the midterm corrections are concerned, what did I say when I sent out the midterm corrections, or when I set you guys out to do the midterm corrections? What did I say regarding the multiple parts? If you got any points off on the question at all, what did you have to do for the parts? Did you just have to do the one part that you got points off? Or did you have to do all of the parts for that question? Yeah, you had to do every single part. Yes, you have to do every single part. Exactly. So for the people who sent me midterm corrections and you only sent me parts of the question, I can't grade that. It's quite literally impossible for me to give you more points because you've essentially done the exact opposite of what I asked. So there's nothing that I can do to help you. I apologize because it might seem a bit unfair, but if you did that, you just didn't listen to directions, and so your midterm grade is just going to stand at what it stands, and that's it. Secondly, I noticed when I was grading the midterm that at least a few of you, like at least a handful, obviously I haven't gone through all of them, so I don't have the full set of data here, but at least a few of you just straight up copied the exact same mistake that you made on the midterm, which tells me one of two things. Either one, you were rushed, which doesn't really make a whole lot of sense because I gave you a week to do midterm corrections, which was, in my mind, pretty generous. Or two, that you just didn't look at the comments that I made on your midterm. You didn't look at all, what was incorrect, and you just said, screw it. I'm just gonna, do whatever and then send it in and hope that I get more points. So either way, not acceptable. That's not okay. If you wanted to do midterm corrections and take this seriously, you should have looked and saw, seen on your specific midterm what you got incorrect. And then lastly, and this one is really like the first two things were like, okay, maybe in some hypothetical situation, you were, away from your computer every single time that I talked about this, or, you didn't see my emails, whatever the case may be. However, the last item on my agenda here that I have to talk about is really what set me off as far as all this is concerned. I got an email from one particular student who I'm not going to name by name, but you are here. So I got an email from a student say that they couldn't make office hours, and that's why their performance on the midterm was so bad, and also that's why the midterm corrections are the way that they are. And to that end, I just have to say, okay, if you couldn't make the office hours, that's understandable, but you could absolutely have scheduled an appointment with me at any time. From the beginning of the semester, I said, if you can't make my office hours, send me an email and I will be more than happy to come up with a time that we can meet. So that's kind of no excuse. And especially it's no excuse for your midterm corrections where you had a full week to do it, because again, I wanted to give you time to come talk to me if there was a specific topic that you really just didn't understand. I said when I gave you guys the time to do the midterm corrections that, I wouldn't answer specific questions on your midterm, but if you had the general topic that you really just didn't understand, yeah, absolutely. Come bring it to my attention. Let's work through some problems together. Let's figure out where you're, getting stuck so that way you could understand it and then do your midterm corrections and, obviously get the most amount of points that you can. So everybody started with the ability to get, a perfect score on the midterm, and then you still started with the ability to get a perfect score after midterm corrections, and that is absolutely not the case now. So some of you, just really took this opportunity and floundered, and I really don't know why. So that's the best thing that I can say is for the people who were following directions and, actually did every single part when I said, do all of the parts, and people who like took me up on my offer to come talk to me in office hours over the course of the week of midterm corrections, good job. That's because, you did things that some of your peers did not. So that's all I'll say on the topic. And if you are in the minority of people who really just, were not following directions for this, I don't really know what to tell you for, the final. The final is not going to be pleasant for you. I'm just warning you now. So in any event, let's go ahead and get started with the homework. I'm sharing the screen already. So what questions do you guys have for me from the most recent homework? I imagine there's going to be at least one person who is confused with question 9. Question 9 was specifically a bit challenging, so hopefully, that comes up. But if it doesn't, it doesn't. Question 9? Okay. Yeah, I figured. Okay, so we'll start with 7 because, okay, yeah, Gianna was asking for 7 anyway. Perfect. Okay, we'll start with 7 because 7 is a good warm-up to 9. 7 is going to be like a good indication of like how we're supposed to try to think about question 9. So let's do 7 together. So for number 7, we're trying to find log of 6. Now, before we try to find this logarithm, we were given some information. So the 2 pieces of information we were given 4 pieces of information total, but only 2 of them are actually going to be relevant for figuring this out. So the 2 things that are relevant are we were given that log of 2 is approximately, just approximately 0.3. And we were also given that log of 3 is, and I'm putting an equal sign, but it's approximately equal to 0.48. Okay, so these were the 2 pieces of information that we were given. Now, the reason that these are important is, notice, you're given a 2, you're given a 3. And when we went over, a class, there was a classwork example, or there was an example that we did during the lecture, one or the other, where essentially your goal was you were trying to manipulate your larger logarithm to kind of be in the components that you could directly substitute in, log of 2, log of 3, and you know what they're worth. They're worth 0.3 and 0.48. So if you can get your larger logarithm to look like log 2 and log 3, then you're in good shape, because then you can do your direct substitutions. So, okay, we say to ourselves, all right, well, what is 6? 6 is the same thing as 2 times 3, right? We can break 6 up into its factors, 2 and 3. So we know that this is the same thing as log of 2 times 3. And now we have a product inside of a logarithm. So because we have 2 things being multiplied and it's inside of a logarithm, we can use our product rule. Our product rule says if we have 2 pieces being multiplied inside of a logarithm, then we can split them up into the log of one of those pieces plus the log of the other. So product rule says that this gives us the same thing as log of 2 plus log of 3. Okay, so again, the idea is first we notice that we are trying to get it in the form of log of 2 and log of 3. That's the hint here. That's the game plan. The game plan is to manipulate 6, so that way we can do that. So we manipulate 6 just easily by breaking it up into its factors. We see that we have log of 2 and log of 3, and by product rule, we can split that up by addition. And when we split it up by addition, now we know what log of 2 and log of 3 are, right? So we can just directly substitute for those. So we can directly substitute and say, okay, well, log of 2 is approximately 0.3, log of 3 is approximately 8, and when you add those together, you get 0.78. So log of 6 is approximately 0.78. You can just use an equal sign here. You don't have to use, the approximate symbol. It's just technically, it's approximately because log of 2 is not necessarily equal to 0.3, and log of 3 is not necessarily equal to 0.48. Like if you plug those into your calculator, it doesn't stop at, just those digits. They are irrational. They go on forever. But having said that, if you, just put an equal sign, that's fine. The idea here is just that you understand that you were supposed to be splitting up 6 into its factors, and once it was into its factors, because it's multiplication inside of a logarithm, you could use product rule to split it up into 2 logs. Any questions on this one before we get to question 9? Okay, so I'm going to move on to question 9 here, but if you have a question, then feel free to stop me. How come you add log 2 and 3 instead of multiply? Okay, so again, that's just directly from our product rule. So product rule says if we have logarithm of any 2 numbers being multiplied together, then you split it up into log of one number plus the log of the other factor that's being multiplied. So just remember that if 2 numbers are being multiplied inside one logarithm, that is indicative of those 2 numbers in different logs being added together. Okay, and again, during the lecture, I said that this is essentially derived from exponents. When you think logarithms, you should think exponents because logarithms are the inverse of exponents. So this logarithm rule is directly from exponent rules. If you guys remember this rule, where you have, like, as long as you have the same base and they're being multiplied, what are you doing? Well, you're condensing it into, one base, but you keep the base the same, which is x, and then you are adding your exponents together, right? So notice how multiplication is indicative of your exponents being added. And here, again, multiplication is being indicative of your logarithms being added. Okay, so this is just a direct consequence of one of our exponent rules. I'm not, again, going to show the proof because it's, it could be a little abstract, and I don't want to confuse you guys, but just understand the similarity between the exponent rule and the logarithm rule. Multiplication is indicative of addition for, a specific piece. Okay? Okay. So that was practice with our product rule and also practice with plugging in. So now with that being said, let's go ahead and think of log of 5. So again, log of 5, you only need the same 2 given pieces. There were 2 other pieces of information, log of x and log of y, but in log of 5, there is no x and y, so you don't have to worry about that. So log of 5. Okay, the hint that I gave you guys to try to get you started is that 5 is the same thing as 10 divided by 2, right? You can always replace 5 with a fraction, and so 5 is the same thing as 5 over 1, but 5 over 1 really isn't going to help you, so we're going to replace 5 with 10 over 2. So that's my first thing that I'm going to do, and again, that was just a hint that I gave you to try to get you started. So we're replacing 5 with 10 over 2. And now, who sees what we might be able to do next? We see here we have a division inside of a logarithm. Do we have a rule for handling division inside of a logarithm? We definitely had a rule for handling multiplication inside of a logarithm. So what does my rule say if I have a division? Yeah, Gianna, we subtract, right? The idea is we're going to use the quotient rule here. So it's going to be the same idea. We're going to take the logarithm that we have here and we're going to expand it. So quotient rule allows us, and same thing with product rule, it allows us to either expand or condense depending on, what's going on. So for one logarithm with division going on inside of it, we can expand this to be two logarithms separated by subtraction. Okay, so this is the same thing as a log of the numerator, which is 10, minus log of the denominator, which is 2. Okay, if you got this far and you got stuck, totally understandable. There's one last key element that we need to be able to solve this. Now, at this point, we know what log of 2 is, right? So you can directly substitute for log of 2. What is log of 2? Well, log of 2, again, that's given to us, right? It's 0.3. So you can just substitute that in. So we know log of 2 is the same thing as 0.3, so this is minus 0.3. But now you have to ask yourself, what's log of 10? What is this? How do you possibly solve for log of 10? Do you have to do some sort of manipulation? Do you have to, try to change 10 around so that way it's in terms of 2 and 3? And if you tried changing 10 to be in terms of, 2 or 3, I imagine that what some of you guys might have tried doing is you might have tried changing that 10 into, let's say, 5 times 2. But doing this is just going to give you log of 5 back, right? When you split log of 5 times 2 up, well, that's going to be log of 5 plus log of 2, and you already have a minus log of 2, so those pieces would cancel out and you would just be left with log of 5 all over again. So this isn't really going to help you out. So instead, what you have to think about is, well, what kind of log do I have? This is log of 10, but what's my base? Anybody can tell me this. What is my base here for my logarithms? Yeah, my base is also 10. My base is a 10 here because this is a common log. Remember that common logs, whenever the base is omitted, it's understood that this is supposed to be a base 10. That's just, the general syntax that we use for logarithms. If there's no number there, then the number is implied to be 10. So this is essentially log of base 10 on 10. Well, we have a rule for this. If we have a logarithm, this is just going back to one of our properties. If we have a logarithm with some base a, and we also have that same exact value in our logarithm, our answer, what this should evaluate to always, regardless of what a is, our answer should always be 1. So log base 10 on the value 10 is always going to give you just 1. And now you can just simplify this. 1 minus 0.3 is just 0.7. So log of 0.5, or I'm sorry, log of 5 is approximately 0.7. And that's how you solve this. This was not easy. I would not put this on a test. I would not throw this on there to as a curveball. Yeah. Why did you make the value 10? Are you talking about right here? Or are you talking about the base? I just want to make sure. The base, I didn't make the base 10. The base was given to us as 10. So right here, again, notice how these are empty spots, right? We have log of 5. The base is not visible. Well, it's understood that this is the common log. And the common log has an implied base of 10 when it's not visible. So log of 5 is the same thing as log base 10 of 5. It's the same thing as if you just wrote out the base. So because the base wasn't immediately visible to you, you should just know that, okay, yeah, the base is obviously 10 here because it's a common log. Okay, so that is this piece of information, knowing that it's a common log, and then knowing the property that, if you have the same base, if this piece matches, the base and the value match in the logarithm, always gives you 1. As long as you knew those two pieces, you were able to solve this. But again, I expected this one to trip you guys up. So, don't feel bad if you didn't get this one. Okay. Do you have any questions on this? Again, the idea here, the first step that we took was we switched 5 up to be 10 over 2. And we did that with the specific purpose of, using our quotient rule. The quotient rule of log says that we can split it up into the log of the numerator minus the log of the denominator. And then once we do that, we could directly substitute 0.3 for log of 2, and we can use our property saying that log of base 10 on the value 10 just gives us 1. Okay, I'm going to imagine you guys are all good with this, and we'll keep going. Okay. Can you do 16 and 17? Possibly. 16 and 17, and I think Olivia also asked for 36, right? Okay, so 16 and 17. All right, so for 16, we have log of x squared, right? This is what we're starting with. Okay, so to work this one out, it's probably best to do the same strategy that we did before on the previous homework. And the strategy that we did on the previous homework was we worked with the inside log first, tried to evaluate or try to manipulate the inside log first. And once we did that, then we'll handle the outside log. So try to start with the inner one first. So starting with the inner one, we know we have our given piece of information, and the piece of information that we're given is log of x is equal to 2, right? This is, what we're given. Okay, so we look at the inside function here and we say, okay, do we have a log of x? Well, close. We have a log of x squared. Now notice this, the square is being directly applied to the x. The square is not being applied to the entire logarithm. The square is on the value. So you cannot directly substitute log of x is equal to 2. It just won't, in this case, that would be incorrect. Okay, if you had, for example, log of x quantity squared, then yeah, you can totally substitute in because it's the entire quantity that's being squared. You don't have an x squared, you just have log of x. Okay, but again, that's not what we have here, so you cannot do that direct substitution. So we have to think to ourselves, okay, how do we deal with this exponent? Well, we should have a rule for handling exponents. What can I do with this exponent here? If I have an exponent applied to my value inside of a logarithm, how do I, move that exponent around? So we talked about the product rule, we talked about the quotient rule, and there's one last rule that allows us to manipulate exponents. Yeah, Aline, bring it up to the front, right? And this is known as the power rule. So the power rule allows us to take the coefficient that we have on our value. So in this case, the value that we have is x, right? We have a coefficient, we have an exponent on x. It allows us to take our exponent and move it out front in front of the logarithm as a coefficient. So basically what I'm going to do here is I'm going to say, okay, well, this is equivalent then to I still have my outside log, and then inside the parentheses, well, now my 2 is moved out in front as a coefficient. So it's 2 log of x. There is now no more exponent that we have to worry about. So we have the 2 out front. We now have log of x. And now, well, we know what log of x is, right? Log of x is equal to 2. So, well, this is the same thing as a log of 2 times 2. And we can simplify that down. Log of 2 times 2 is log of 4. And now that we have log of 4, okay, well, we can try to, mess with things. But, I mean, we also have the other piece of information, which is log of 2 is equal to 0.3, right? This was the other piece of information. Again, there were 4 total. One of them I actually don't think came into play at all. Log of y equals 3. I don't think you guys actually needed that for any of these questions. But we definitely need log of 2 is equal to 0.3. And the reason that we need it is, okay, if you multiply the 2 and the 2 together, that's okay. If, you got to log 4 and you realize, oh, I actually need to take a step back. This isn't, the direction that I need to go. The reason that this isn't the direction you need to go is because notice how you already have 2 values being multiplied inside of a logarithm. And you're trying to get log of 2 by itself. Right now you have log of 2 times 2. Well, we have the product rule, right? The product rule says if I have 2 pieces being multiplied inside of one logarithm, I can just separate them out. So, okay, well, this is the same thing as log of the first 2, right? That's the first one, plus log of the second 2. So, cool. We have 2 logarithms here, log of 2 plus log of 2. And when we go ahead and do our direct substitution, again, doing our substitution here for log of 2, we know both of these are equal to 0.3, which gives us an answer of 0.6. And for the record, there's another way to do this. The other way that you could do it is once you do your power rule from this point here, you can notice, oh yeah, you have multiplication of 2 pieces that you actually already have the given information to, right? You have 2 and you have log of x. Well, you know what log of x is worth, and you also know what log of 2 is worth. So you could try splitting it up from there, although it could get a little bit messy. So I'm just warning you now, that is something that could happen. But for the record, this is, the way that you should try to handle it. And it's just all about using the three rules that we talked about in the last lecture, right? The product rule, the quotient rule, and the power rule. And then once you manipulate it enough, you get it into its, bare bones basic version where it's, log of 2 or log of 3 or log of x, whatever the case may be. And you're just doing your direct substitution based off of the given information. Okay? So again, just to recap this, we started with log of x squared. We worked with the inside log first. We pulled our coefficient out front of our inside logarithm because our exponent, again, our exponent from the power rule says, okay, well, our exponent just becomes our coefficient. And also vice versa, if we needed to, we could go backwards, right? If we really needed to, if we said, okay, no, this is incorrect, or maybe we actually wanted the exponent, we can take our coefficient, and our coefficient could become the exponent of this value inside the logarithm. Okay, so don't think that it only goes in one direction. An equal sign, implies that you can do both. Okay, but in any event, the idea here was that, we took the exponent, brought it out front, and that became our coefficient. We had log of 2 times 2, and we say to ourselves, oh yeah, we have two pieces being multiplied. We can just use the product rule. And product rule, we split it up into two logarithms separated by addition. We can do our direct substitution, and we get 0.6. Any questions? Okay, so let's go ahead and do 17 together, and we'll take it from there. We'll probably do 36 right after this. So 17, we have log of the cube root of 48. Log of the cube root of 48. Okay, so for this one, who thinks they can help me at least just get started? One of the first things that I told you guys is that if you're dealing with logarithms, you should try to convert things to exponents, right? We don't really like radicals. So who can help me get started? I don't want to deal with this radical. I just want to make it into an exponent. How do I convert radical 3 to be an exponent? Yeah, exactly. So radical 3 is indicative. It's the same thing as an exponent of 1/3. So we can write this as log of 48 to the 1/3 power. Remember, the index tells you the denominator of your exponent. So again, 3. And the power on 48 tells you the numerator, right? 48 is just assumed to be to the first power. So that's just your numerator, right? Your numerator is just 1. So we just write 48 to the 1/3 power. That's how you convert a radical to an exponent, a rational exponent. Okay? Okay, so we have log of 48 to the 1/3 power. Okay, cool. I don't want to deal with this 1/3, right? What I can do with my power rule is I can bring it out front, right? My power rule says if I have an exponent being applied to my value inside the logarithm, I can take that exponent, move it out front, and that becomes my coefficient, right? So now it becomes 1/3 times log of 48. And that's just by power rule. Okay, well, now, again, we've been playing the game. We've done it 3 times now, right? Where we had some larger value and we wanted to deconstruct it into the, the given statements, right? The given statements were log of 2 is equal to 0.3 and log of 3 is equal to 0.48, right? So if I can break 48 to be into 2 and 3, then okay, well, I know that if it's being multiplied or if it's being divided, I can split those things up, right? I can split those numbers up by either my quotient rule or my product rule, right? So I just need to try to find a way to split up 48. Well, I mean, if you're looking for 2, even if you don't immediately see that 48 is divisible by 3, that's okay. If you're looking for 2 anyway, you say to yourself, oh yeah, 48 is even. Well, if 48 is even, then I know there's at least 1 2 hiding in there. So sure, we can take 1 2 out of it. So this becomes log of 2 times, well, 2 times what number gives you 48? The answer should just be 24, right? Okay, so sure, we've gotten 1 log of 2. right? Because we know that eventually we're going to split this up by product rule, and product rule says we're going to have log of one of the factors and then log of the other factor, right? So yeah, we have log of 2 right now. That's perfect. We know that we'll be able to directly substitute for that number later. So, okay, sure. Then you just keep working. 24. What's 24? Well, once again, even if you don't see the 3 immediately, 24 is an even number, right? So you can take another 2 out of that. So, sure, this is the same thing as 1/3 log of 2 times 2, right? The first 2 I'm just bringing down. The second 2 I'm taking out of the 24, and what's left? 12. Okay. Well, at this point, you should be able to see, oh yeah, 12 is divisible by 3, right? I can take out a 3 from here. So taking out a 3, we have 1/3 of log of 2 times 2 times 3 times 4. And now I'm not even going to do one more line. You should be able to see at this point, 4 is really the same thing as just 2 times 2, right? So we have 2 more 2's. And that's it. The entire idea of breaking this down, deconstructing it, decomposing it, is we wanted to try to decompose 48 to be in terms of 2 and 3. Because if we can get log of 2 and log of 3, then we know what they're worth. It's worth 0.3 and 0.48. So all we're doing is, we're just doing this piece a whole bunch of times. And at this point, you have your choice. You can either, write out each logarithm by product rule. Product rule says you're going to have the log of this 2 plus the log of this 2 plus the log of this 2 plus the log of this 2, and then plus the log of this 3. But I'm going to take a small shortcut here. I'm going to rewrite this as, so we have 1/3 log of, how many 2's do I have in total? I have 1, 2, 3, 4, right? And so if I have 4 2's being multiplied, this is the same thing as log of 2 to the 4th. And we still have that 3 left over. Again, this is just a small shortcut to cut down on writing, but if you feel that, you just want to cut to the chase and just write each logarithm out by the, splitting up by the product rule, totally fine. That's totally acceptable. And now at this point, I'm going to use my product rule to split up each piece. So now I have log of 2 to the 4th plus log of 3. What can I do with this 4? Well, with this 4, I can move it out front, right? So I can, again, the 4 is just the exponent that's being applied on my value. Power rule says I can break that out front. And for the record, it's 1/3 times this entire piece, right? Don't forget this 1/3 has been multiplied by the entire logarithm. So when you split up the logarithm, it's 1/3 times the entire thing. So we have 1/3 times 4 log 2 plus log 3. And again, we know what log 2 is. We know what log 3 is. We can do our substitution at this point. So our substitution, we have 1/3 here, 4 times 0.3 plus 0.48. And for this one, I would imagine you would probably just start using a calculator, but I can get it fairly far. So we have 1/3. 4 times 0.3 is going to give you what? What is that, 0.12? No, 1.2. Oops. Okay, so you have 1.2 here plus 0.48, and simplifying that gives you 1.68. So you get 1.68 divided by 3, and then you can simplify this. If you can't use the calculator, because again the directions said don't use a calculator, totally fine. Just leave it like this. This is no big deal. Because again, this is, as far as I would expect you to take it. But again, the entire idea here is not necessarily the value that you get at the end. I'm really not concerned with, this number. This number could be whatever. What I'm mainly concerned about is your proficiency to use the product rule, the power rule, and the quotient rule, right? Again, the entire idea was that we were starting with some big composite number, 48, and the hints that we were given was that we know what log of 2 is, we know what log of 3 is, so if we can break 48 down, then we can break 48 down, into its 2's and into its 3's. Then we know what everything's worth, right? We can split it up, and we can, do our direct substitution, and, we'll end up with some value down the road. Does anybody have questions on this? Again, I'm not really concerned with this number right here. I don't care that it's 1.68 divided by 3. I don't care, if you can, do that in your head or not. I don't, whatever the final answer is, it is. That's, really not my concern. My concern is these pieces right up here. So like understanding how to convert your radical to an exponent. Understanding that you can take your 48 and just break it up into two pieces. You're trying to factor 48 over and over and over again, so that way you get what 48 is worth, but just in terms of 2 and 3. And also understanding to go from two pieces being multiplied to two different logarithms separated by addition, using power rule, using the using power rule, using the product rule. Just want to make sure all of this is hitting home with you guys. Are we okay? Because I'm going to move on to 36 here, if silence is going to be the answer. Okay, so I'm going to move on to 36 here. If you guys have questions, please let me know. So 36. Okay. So with everything that we've been doing recently, with those logarithms, with 7 through 17, those were, basically we were trying to split up the logarithms specifically with the idea of substituting in for log of 2 and log of 3 or log of x, right? 36 is similar in that we do definitely want to expand, but we're expanding not with the idea of substituting, with the idea of we have one logarithm and it's a really beefy logarithm, as I'm sure you guys can look. I mean, when you looked at that homework, I imagine you took a look at that question and you were just like, dude, really? So the idea is we're just taking that really, big monster of a logarithm and breaking it down into several different logarithms using our rule, or rules, I should say. Okay, so we're starting with the natural log of, and I'm just going to write parentheses. Remember, a bracket is the same thing effectively in mathematics as a parentheses for, when you're writing things in equations. So this is in the numerator, we have the cube root of 2x plus 1. So we have a cube root right there. And this is being multiplied by a factor of x plus 1. So that's our numerator. And then our denominator is x minus 1 squared. And this is being multiplied by another factor of 3x plus 2. Okay, so this is what we're given. Now, to be able to solve this, we did look at somewhat of a beefy logarithm that we were trying to expand during the lecture. Now, in the lecture, I said, yeah, you have a lot of multiplication going on, and it's not incorrect to attack the multiplication first. But if we see here, the real linchpin of this entire logarithm is this big division that's going on, right? We have a huge numerator being divided by a huge denominator, right? So what we can do is, well, let's just take care of the division first, and then we'll worry about the multiplications, after the fact. So if I want to use my quotient rule here, I'm just going to call on somebody who I haven't called on in a while. I don't know. Shelby, if you can help me out. I want to use my quotient rule here. And quotient rule says, okay, well, I'm splitting up one logarithm into 2. And because, there's division going on inside. What's my first piece? If I want to separate this, what is my first logarithm going to be?
The cubed 2x, not cubed, cubed root of 2x plus 1 times x plus 1 minus the x minus 1 squared times the 3x plus 2.
Okay, cool. You took it the whole way. Totally fine. So yeah, so
Sorry.
we're again, no, that's absolutely fine. So again, notice we're starting with a natural log. So make sure that each logarithm that you bring down along the way is a natural log. If at some point, hypothetically, if you wrote instead a log here, that would technically be incorrect because again, what is the base of a natural log? The base of a natural log is e, right? The base of this log would, if you didn't write a base, would just be 10. So these are two different logarithms, so make sure you're writing the correct one here. So we were given natural log, so we stick with natural log. Okay, so just like Shelby said, and if you missed what she was saying, we use quotient rule to split up one logarithm to be two logarithms, where our first log is going to be everything that's inside the numerator. So notice that the first log matches the numerator, and then the second logarithm is going to be everything that's inside of the denominator. So this is going to be the x minus 1 squared times 3x plus 2. Okay, cool. So we're already, doing good expanding. As you can see, we started with one logarithm, now we're up to two, right? Expanding means, in regards to logarithms, the number of logs are going up. So, okay, sure. We're going to now do some similar steps here. We have multiplication going on, right? We have the multiplication of this cube root times the piece x plus 1. So again, calling on somebody else, Kayla, if you can help me out, I want to just use one of my rules here so I can split up this logarithm even further.
How would you start? Sorry, I'm just a little confused.
Okay, so we have three rules for logarithms for expansion, right? We have the quotient rule, which is what Shelby just used, right? Quotient rule says if we have one logarithm, we can, and there's division going on, we can separate it into two logarithms where you have the numerator and the denominator, and it's separated by a subtraction, right? Product rule, which is the opposite of that, is if we have two things being multiplied, we can split it up into two logarithms separated by addition, right? Okay, so I have one piece here being multiplied by another piece here, right? You can think of this entire thing as just one letter. Think about it like, just A. And think about this entire piece as just another letter, B, right? So in theory, product rule says I could just split this up into log of A plus log of B. So what would this look like? Let's start small. What kind of log am I using?
Are we doing the first rule division?
I'm sorry, you're a little bit garbled because of Teams. Can you repeat that?
Are we going to do the first rule that we did in the first example?
Yeah, so we're just trying to use product rule here, right? So product rule is just saying, okay, well, I have, if I have two things in a product, right? I have two things being multiplied. Well, this is the same thing as log of that first piece plus log of the second piece, right? So what I was asking you was what kind of logarithm we have. We have a natural log, right? So I'm going to keep my natural log, and now it's going to be the natural log of the first piece, which is cube root of 2x plus 1. That's a 3. Cube root of 2x plus 1 plus the natural log of x plus 1. Yeah, all we're doing is we're just splitting up the logarithms, because it's multiplication. We know that we're going to have our logs being added together, and it's just, the values are going to be the first piece times, and the second piece, the things that were being multiplied together. Okay, so, okay, cool. We've split that up now. Great. And over here, we're going to do the same exact thing, right? The reason we're going to do the same exact thing is that, well, we have two things being multiplied, right? We have an x minus 1 squared times 3x plus 2. So what I want to do is I want to do the exact same thing. Now, just be careful. You already have the subtraction, right? And notice how the subtraction is being applied to the entire logarithm. So when you split this up, everything that you split this up into, when you break the one log into two logs, those two logs better still be being subtracted. Okay, the negative sign has to be applied to both. So I'm going to put parentheses here because, again, when I break the one log up into two logs, both of them are being subtracted. Okay, so we know that we're going to have the natural log, right? And again, we're going to use product rule. Product rule says I have two things being multiplied. So it is the natural log of the first piece, which is x minus 1 squared. And then this is going to be plus the natural log of the second piece, which is 3x plus 2. Okay. And now before we even get going with, other things, who can help me out just with this piece right here? I have an x minus 1 quantity being squared, right? The square is to the piece that is inside of the natural log, right? It's not the entire natural log being squared. It is just the x minus 1 inside the natural log. So what can I do with this exponent? Aline said it before, so somebody that's not Aline. Come on, I believe in you guys. Power rule, right? What does my power rule tell me? Yeah, you can move it out to the front. Exactly, right? I have my exponent. So power rule says I can just move it out front, and that becomes my coefficient. So great. I can now simplify this even more, right? So when I rewrite this, I'm just going to move the 2 out here, okay? So I just handled the exponent in the same step. If it helps for you to rewrite the entire thing all over again with just that small change, go for it. Just with the interest of time, I just wanted to take care of that right now. Okay. Okay. And now, again, remember your negative sign is being applied to both the logarithms. So your negative sign is being applied to this piece and also to this positive piece right here. So what you're doing is effectively you're just switching the signs of all of these pieces. So when I get rid of this parentheses, it's negative 2 times the natural log of x minus 1 minus the natural log of 3x plus 2. That was a plus, sorry. Okay, so I just distributed that negative sign, again, in the same step. Okay, so now, okay, we're making good progress, right? We started with 1 logarithm, and we're already up to 4 logs. So we're definitely expanding. Things are getting, more and more expansive. Okay, next thing. So we just talked about power rule, right? What is a cube root? Cube root is essentially indicative of an exponent, right? We already talked about how to convert radicals to exponents, and in fact, the last example that we did that was a cube root. So we know that the cube root of 2x plus 1 is really the same thing as 2x plus 1 to the 1/3 power. And once again, 1/3, because it's an exponent, we can just bring that out front for that first for this first logarithm. So we have 1/3 of the natural log of 2x plus 1. Okay, so that's how we handle the cube root, and that's how you handle your exponents. Okay, so now let's go ahead and see, is there anything else that needs to be simplified? We have, the natural log of 2 pieces being added together. Can we split up things that are being added together? No, we cannot, okay? Do not think if you do this, if you have the natural log of 2x plus 1, this is very much not equal to the natural log of 2x plus the natural log of 1. These are not equal, okay? The reason these are not equal is that, remember, for 2 logs to be added together, this is indicative of multiplication happening inside of the, the original value. It should have been a multiplication, not an addition. That's product rule, right? Product rule is when you have 2 things being multiplied in 1 logarithm, you can split it up into the log of the first plus the log of the second. If 2 things are being added inside of 1 logarithm, you cannot split it up. Okay, so, well, we have then the log of 2x plus 1. We can't do anything with that. We have the log of x plus 1. Can't do anything with that. And again, all these pieces have either subtraction or addition in them, right? So that's it. You're done. This is as expansive as it gets. There's nothing else to be done. You handled all your exponents. You handled all the multiplication. You handled the division. This is going to be your final answer. Okay, so does anybody have questions on the steps that we took to be able to get to this point? Again, for me, I always find it easiest to deal with the division first to get rid of fractions. If you wanted to handle the multiplications first on the top and the bottom, totally acceptable. That's absolutely an okay thing to do. It just, might get a little bit messy. Well, I mean, this was already messy, so that's okay. But it might get a little bit more messy. And for that, with that being said, you might get a little bit confused, but the entire idea is the same, right? You're using your rules of product rule and quotient rule and power rule to try to simplify things down. So the first thing we did was quotient rule to split it up into 2 logarithms separated by subtraction. Once we did that, we saw that in each logarithm there was multiplication going on. So for each of these logarithms, we can split it up into 2 more logarithms each, where it's log of the first piece being multiplied times log of the second piece, right? And again, the important takeaway here is don't forget to distribute your negative sign when you're splitting up your logarithm. Yes, Deborah.
Wouldn't you be adding ln, open brackets, 3x plus 2 at the end?
So the reason that this is a negative sign is, remember we have a negative right here, right? So this negative is being applied to this entire logarithm. And when we split up this entire logarithm, we got the, this piece right here, and we got this piece right here. And if we didn't distribute the negative sign, the negative sign was outside here, right? And we had the plus. And I see why you think that this would be a plus sign, because product rule says, okay, yeah, when you have, when you have a log and you have two things being multiplied, you split it up into the first piece plus the second piece, right? But the reason why it's negative is because this negative sign gets distributed to each piece. So the negative sign gets distributed to the first log, and it also gets distributed to the second log. So it's no longer plus natural log of 3x plus 2. Now it's minus natural log of 3x plus 2. Does that make sense? Okay. All right, guys. So that's it. There's a couple of you that, if I recall, I emailed you last night to just stick around, come talk to me. So if you wanted to come talk to me, regardless, just stick around. For the people who, again, I wanted to talk to you, please stick around. Everybody else, that's it for today. I will have your midterm corrections back to you. And for the record, if, again, going back to what I was talking about earlier, if you sent me only, the specific parts that you got wrong and not the entire questions, I'm sending you back your midterm corrections saying that I can't grade it. Okay? So it's just that easy. So I'm going to end the recording here, guys. Enjoy the rest of your day, your Veterans Day, and have a great one. I will talk to you on Friday.